The graph of f is shown below. A total of 24 right-hand rectangles are shown. So what do you mean by right-hand rectangle? So there's clearly 24 rectangles. You can count them. And right-hand rectangle means that for each of these rectangles, the height of the rectangle is defined by the value of the function on the right-hand side of the rectangle. So you can see this is the right-hand side of this first rectangle. And if you take the value of the function at that point, that is the height of the rectangle. A left-hand rectangle would define the height of the rectangle by the value of the function at the left-hand side of the rectangle. So a left-handed rectangle's height would be, the first rectangle would look like that. So that's what they mean by right-handed rectangle. Fair enough. 8 in blue, we see that. 16 in red. All right. All 24 of the rectangles have the same width. Which of the statements below is or are true? And they give us 3 expressions in sigma notation. And they say, like, this first one is the sum of the areas of the blue rectangle. This is the sum of the areas of the red rectangles. This is the sum of the areas of all the rectangles. So I encourage you now to pause the video and try to determine on your own which of the statements is or are true. So I assume you've had a go at it. So let's just go through each of these and see whether they make sense. So this first one, the sum of the areas of the blue rectangles. Well, we know we have 1, 2, 3, 4, 5, 6, 7, 8 blue rectangles. And we're summing from 1 to 8. So it seems like we're summing 8 things right over here. This is 1, 2, 3, 4, 5, 6, 7, 8. So this is looking good right over here. And then we take f of something times 1/2. And so, not even looking at this yet, it looks like this would be the height of each of the rectangles. Remember, we're taking the value of the function on the right-hand side for the height, and this would be the width. So does it make sense that the width of each of these rectangles is 1/2? Well, the total distance between x equals -5 and x equals 7, that distance is 12. 5 plus 7. That's 12, and we're dividing it into 24 rectangles of equal width. So if you divide 12 divided by 24, each of these are going to have a width of 1/2. So this is checking out, that the 1/2. And now let's think about this part. Let's think about the f of -5 plus I over 2. So let's see, when I is equal to 1, so we're going to take 1/2 times f of -5 plus 1 over 2, right? I is 1. So -5 plus 1/2 is going to get us to this point right over here. F of that is going to be this distance, this height right over here. And this is consistent with these being right-handed rectangles. So this is definitely the case. When I is equal to 1, we're definitely finding this area right over here. When I is equal to 2, it's going to be -5 plus 2 over 2. So 2 over 2 is we're going to add 1. We're going to go over here. And so once again, we're doing 1/2, which is this right over here. That's the width, times f of -5 plus 2 over 2, which is f of -4, which is this height right over here. So once again, that is that area. And you can keep following it. Every time we're taking the function, we're starting it, this first one is -5 plus 1/2. And then for each increment, we're adding a half to, I guess, the right-hand side is one way to think about it. So this actually makes complete sense. And we're doing this for the first 8. So this is indeed true. This is the sum of the areas of the blue rectangles. Now let's look at this one over here, the sum of the areas of the red rectangles. At first, this looks pretty interesting. We're taking the sum of 16 things, and we do indeed have 16 things right over here. We have the width of each of those 16 things, or for each of those things, we want to figure out an area, and it is indeed the case that each of these has a width of 1/2. But what happens when we take f of -1 plus I over 2? So we're starting right over here at -1. -1 plus I over 2. When I equals 1, we're going to be at this point right over here. And f of that is going to be, you might say, hey, isn't that going to be the height of that rectangle? When I equals 2, isn't it going to be the height of that rectangle? And when I is equal to 3, isn't it going to be the height of that rectangle? And that's where we have to be very careful. They're going to have the same absolute value, but these are all going to be negative values. these are all going to be negative. Because we see between this value of our function, so that looks like between negative 1/2 all the way to 7, our function is actually negative. So one way to think about it, you'd be having negative heights. So when you multiply these two things, you're going to get a negative number. So these are going to be, this whole thing is going to be a negative number. And so you're essentially going to get the negative of the sums of the areas of the red rectangles. But that's not the same thing as the sum of the areas of the red rectangles. An area is, at least in the traditional sense, you would expect to have, well, if you were just saying, what's the area, how much carpet you would need to cover this, someone would say, well, that would be a positive value. But this is going to be a negative version of that. So that is not the sum of the areas of the red rectangles. It's the negative of the areas of the red rectangles. So we'd ruled that one out. And then this last choice. So this expression is the sum of the areas of all the rectangles. And so this was going from I equals 1 to 24. So it's literally 24 things. It's starting here and it just keeps going. And if this said from I equals 1 to I equals 8, it would be the first choice. But then this falls into the problem again of once we get past, when we get to I equal 9, this thing right over here will turn negative, and it's going to give the negative area. So it's essentially going to net out this positive area against this negative area right over here. So it's not the sum of the areas of all the rectangles. It's going to be this area essentially minus this area right over there.